Hello everyone, welcome to the second part of the solving equations with brackets video tutorial. Now, this is, I've just put in this video just as a little extra type of, an extra type of approach you can take towards working with some of these solving equations with brackets questions. Now, there's often schools and textbooks discourage against this way because it's effective to a point but gets a little bit confusing when we start adding algebraic terms like we would before, like we saw, sorry, in the later questions from the previous video. But I think it's still important to discuss because it teaches us that there's always another way to get to the same place in maths, and we can still utilize any tool we have to solve these types of questions. So I'm going to start with the very same question we did in the previous video, and I'm going to show you another way we can sort of think about this. And it's kind of up to you to choose which way you'd sort of prefer to use. But with this question, we can do it again in the same way we did when we solved systematically by considering the last thing that was done to my x. Now, if we think I first started with my x, then I added 2, then I multiplied all of that by 3. So, the very last thing I did to my x was multiplying it by 3. So, I can say, well, 3 was multiplied by x plus 2 to give me 18. So what should x plus 2 have been? Now, let me draw my little arrows like I've done before. So 3 is multiplied by some number to give me 18. How can I find that number, that mystery number, x plus 2? Well, I can do the opposite of multiplying by 3, which is dividing by 3. And that's going to kill my 3 out the front. And I get left with x plus 2. Well, what number times by 3 to give me 18? Well, that number is just the same thing as when I divide 18 by 3, and that is 6. And then now I have actually a very simple solving by inspection type of question where, you can look, if you know how to add numbers, you can pretty easily see what x is going to be. But let's just double check it using what we've done so far. So I added 2 to x and I got 6. So x would just be the difference between 6 and 2. So I'm going to minus 2 from each end. That gives me now x equals 6 minus 2 gives me 4, which is the exact same thing I got in the first example of my previous video. Now let's try one more of these. So, well, actually, let's try 2 more. So here I have 3 outside of 3 plus 6e. Oops. Equals 27. Okay. Now, once again, I can kind of think about this in the same way. Looking from the perspective of e, I first multiplied 6 to it, then I added 3 to that, and then I multiplied all of that by 3. So the very last thing I did once again was multiplying by this 3 here. So I can think of this systematically. I can think about it through the lens of how we solved these equations in the previous few videos, systematically, sort of one step at a time. So I want to find out what number multiplies by 3 to give me 27. And if you know your times tables, you should be able to pick this one up. But I'm going to once again do the opposite of multiplying by 3 to undo this thing here. And that gives me, on the left-hand side, 3 plus 6e. Sorry, I don't need this anymore, this bracket. 3 plus 6e gives me 27 divided by 3, which is 9. Okay, so we're getting a little bit closer. Now, once again, I have e, I've times it by 6 and added 3 to that. So I can find what 6e is by doing the opposite of adding 3, which is subtracting 3 from both sides. Because this is going to get rid of that one there. And it's going to give me what 6e is. Because I know when I add 3 to this thing 6e, I get 9. So 6e must be the difference between 9 and 3. So 6e is 6. And here we want a value, a number e, which when multiplies by 6 gives me 6. So I can once again do the opposite here. I can divide by 6, and I get that e equals 1. Cool. Let's try one more here. And you'll see here, at this point, I would advise you personally that I would only use this way once when your questions are in this type of form. When we start adding algebraic terms, it gets a little bit confusing because there's kind of just more rules to sort of remember. But we'll do one more question in which you'll be able to see what we how we can use this method. But as I said before, it starts to get a little tricky and more mistakes can sort of happen. So I always like the expanding first strategy, but this gives you just another way to think about these types of questions. Okay, so you can see I have an extra algebraic term here. Now, I still want to work with my expression here. And then I only want to add the algebraic term here, sort of at the end when I have to get it into a nice solving simultaneously, a nice way to look at it. So here I can say, well, timesing this whole thing by 4 was the multiplying by 4 was the very last thing I did. So I'm going to divide both sides by 4. But now where this gets tricky is in dividing by 4. Oops, sorry about that. In dividing by 4, I am not only dividing this entire expression as well as this side, I also have to divide this thing by 4 as well. This is why I don't like this method up to a certain point. This is why I like expanding first, because it gets a little tricky at times. But I want to divide everything now by 4. So 4f divided by 4, that's just going to give me f. Now, dividing this entire expression by 4 leaves me with 2f plus 2. And my right-hand side, dividing 44 by 4, gives me 11. Now, once again, I can add my like terms now. So if I have One lot of f, I add it to two lots of f. That gives me 3 lots of f plus 2 equals 11. Cool. So once again, I can see I have a solving systematically type of equation here. So once again, I sound like a broken record a little bit, but I have my f, and we want to look at what the last thing was done. The last thing that was done to it mathematically. So we times by 3, and then we added 2 to all of that. So to find 3f before I added the 2, I'm going to subtract 2 from both sides. So kind of working backwards. I'm sort of looking in the past. I'm saying, well, 3f plus 2 gives me 11. Then what was 3f before adding 2? And that I'm going to get, when I minus 2 from 11, I get 9. So I get that 3f equals 9. Now, finally, once we get to this point, I can divide both sides by 3, because here I have 3 times f. I have 3 lots of f, gives me 9. So I can find f by just dividing both sides by 3. And that's going to give me that f equals 3. Now, as I said, once you get to these types of questions, like the one in question 3, I don't like this method as much because you have to just do more. The work ends up getting a little bit harder. Now, when you get kind of simpler questions like this, where there's less steps and less algebra you have to do, this way kind of still makes sense from a solving systematically mindset. But if this way works for you, cool. If it doesn't and it gets a little bit confusing as you go through these types of questions, like I said in the last video, we can also look to expand first. And then, sorry, that looks a bit messy, but we can always expand first, then add algebraic terms. But these are two ways we can go about solving equations when brackets are involved. So we'll talk about fractions in the next video, but thanks so much for joining me today, and I'll catch you next time.